Hello everyone. Today for lecture I'm going to be talking about three different things. First I'm going to discuss the idea of measurement scales, which is pretty strongly linked to the idea of data types and different types of data, different measurement scales. And so that links back to what we talked about last week with raster versus vector data and things like that. So I'm just going to discuss considerations and limitations related to different measurement scales and types of data. Then I'm going to talk a bit about data symbolization, give you some tips for cartography, so how to effectively display your data, and some tips on how to lay your maps out to make them look nice, because thus far we've just kind of had you make maps with little consideration for what they actually look like. But as we progress for labs 3 and 4, and then especially for your final project, you're going to be marked a bit on how the data is actually presented, right? Do you do an effective cartographic visualization? And then I will discuss a bit about the GIS research process and link that to the introduction for lab 3. So the first thing that I want to introduce today is the idea of measurement scales for data. Broadly speaking, there's two different categories, qualitative and quantitative. Qualitative means some sort of quality. It's a descriptive type of measurement scale. There's no numeric data linked to it. And then quantitative, and quantitative means numerical. Within each of those, there are two subtypes. So you have either nominal or ordinal for qualitative data. So nominal is just categories. There's no order, direction, ranking. One nominal category is not any more or less, better or worse than another nominal category. They're just different. Then you have ordinal data, which is categorical still, but it's ranked. So one category can be higher or lower than the next, but you can't actually measure the difference between them. And then we have the two types of quantitative data. We have interval and ratio. So interval data, you can take the differences between them, but there's not a true 0 point. And I'll elaborate a bit on what that means in just a moment. And then ratio data, you can take, you can do all the mathematical operations with ratio data because there's a true fixed 0 point that actually has some physiological meaning to it. So you see in the table on the right the different operations that you can do with the different measurement scales. So nominal data, you're quite limited in what you can do. You can say, is this category equal to this category or not? And you can basically take counts of the different categories, but that's it. With ordinal data, you can do, is it equal or not? You can take counts, but you can also rank it so you can get the order. And with that, that allows you to calculate the median or like the most common value, but you can't do anything beyond that. With interval data, you can also add and subtract, but you cannot multiply and divide. And so I'll explain why in a moment. But you can also take the mean of interval data. And then with ratio data, you can do any mathematical operation you want. To elaborate a bit, nominal data is a type of qualitative data. And so it's just a name or a category. There's no ranking or order or direction. So some good examples might be plant species. It doesn't matter whether it's a wild rose or lupine or a salmonberry. They're different types of plants, so they are different categories. But one plant is not inherently more or less than, or any better or worse than another. They're just different, distinct categories. Other options might be things like zoning category, language spoken at home, race, things like that. So again, it's just a descriptor. It has no weight, ranking, anything behind it. The other type of qualitative data is ordinal. So this is more than just a name. There's some sort of ranking, but there's no numerical scale or meaning behind it. So you can't take differences. So think of like relative sizes. short versus medium versus tall, like you can rank those, but what is the difference between short and medium? Everyone might have a slightly different definition for that. Or relative ages, young versus old. So again, young is less than old, but how much, right? That's relative. It might depend on what you're talking about. If you're talking about people, 2 might be young, 70 might be old. If you're talking about trees, 70 might be fairly young or middle age because trees can live hundreds and hundreds of years. So again, it's a relative ranking. It's just descriptive, but it doesn't have any quantitative meaning behind it. Now you can abstract some sort of numerical scale into an ordinal data scale. You can take numbers and classify them, and we'll talk about data classification next week. But you can take numbers and classify them and represent them as old or young, but you can't go the opposite direction. So a good one that everyone can probably relate to would be spice level, for instance. Mild, medium, or hot, right? You see those peppers or the spice level used to describe things all the time. And there is some ranking to it. Hot is definitely more spicy than mild, but everyone has a different definition of what mild, medium, and hot are. Something that's mild to someone might be very hot to another person. Looking at qualitative data, we have the interval measurement scale. And so this is data that has a numeric scale, some numeric value to it, but the 0 point is arbitrary. So that might sound a little bit confusing, but hopefully I can help clarify. So some good examples of what I mean by that, or some good examples of interval data would be time or dates, right? So we chose the year 0 very, very arbitrarily. It's just the theoretical day that, like we picked out of thin air that's related to when Jesus died, apparently. But it's a very arbitrary choice of year. There is no true beginning or end to time. It's just this continuous thing. So, 2021, what does that mean? Well, it's, 1 year more than 2020, but you can't divide or multiply it. Same thing with time during the day, right? So like, 3 p.m. is not half as much as 6 p.m. It's 3 hours difference, but you can't divide or multiply. So the best way to think of it and to ground your idea in it would be temperature, for instance. The Celsius and Fahrenheit measurement scales are interval, whereas Kelvin and Rankine are both ratio. And so Kelvin is essentially the same thing as Celsius, except the 0 point is set to absolute 0, the coldest temperature possible, where a molecular motion stops. And Rankine is essentially the same thing, but it's just in the same unit as Fahrenheit. But we'll focus on Celsius and Kelvin for now. So if you're looking at Celsius, it's an interval data scale. The 0 point is just somewhat arbitrarily chosen as the freezing point for pure water at sea level. And so you can add and subtract, you can calculate the mean average temperature, but you can't multiply or divide it and have it mean anything physical. So 20 degrees Celsius is not twice as warm as 10 degrees Celsius. It's 10 degrees more than 10 degrees Celsius, but it's not twice as much of anything. Because again, that 0 point is somewhat arbitrary. However, if you're working with Kelvin, because that is directly tied to the motion of molecules and 0 being the point where all motion stops, 20 degrees Kelvin is twice as much energy as 10 degrees Kelvin. So interval data is a bit of a hard one to wrap your head around, but try and just remember the difference between like Celsius and Kelvin, for instance, or think about the arbitrary nature of dates and times when you think about it. Ratio data is a numeric scale where the 0 point has some physical meaning. And so this is typically most of the numeric data that we work with in GIS. So some good examples would be Kelvin as far as temperature goes, but other options would be height, for instance. So height starts at 0 and goes up from there. The 0 point for a height measurement would be no height at all. So it has some physical meaning. Same thing with income. If the income is 0, it is no income at all, and it goes up from there. Housing cost, the cost of a house starts at 0 and goes up. Population, you can start at 0 people and you can go up from there. So with ratio data, you can do the full suite of mathematical operations. If you look back to that table on this slide, right? So with ratio data, you can do everything. With interval data, you cannot multiply and divide, and that's the key distinction there.